Welcome to today's class. Previous class we discussed Coulombs Law. Today we are going to discuss Coulombs Law itself, that is vector form of Coulombs Law. Okay, and we will be discussing some problems also. So first of all, let's recollect what is Coulombs Law. So according to Coulombs Law, the force between two charges. So if we have two charges Q1 and Q2 separated by a distance r, the force between the two charges it's given by 1 by 4 pi epsilon 0 Q1 Q2 by r square. This is what Coulomb's law states about magnitude. Now we already discussed the direction also. That means the force between two like charges will be repulsive and between unlike charges will be attractive, and the force acts along the line joining the centers of two charges. Now it is that point we are going to discuss. So how can we incorporate that direction in that equation? This is only a scalar equation which gives you the magnitude of force between two charges. So to incorporate that direction, let's consider the situation where you have two like charges. We are considering two like charges. So I am drawing a vector diagram showing the forces in vector form. That's what I mean. So we have two charges. This is Q. This is also Q. So suppose they are equal charges. So this is the line joining the two charges and the distance is R. Okay. Now Now this is the line joining the two charges and the distance between the two is r. Now since these two charges are like charges, they repel each other. So this charge, suppose this point we call A, this point as B. So charge at A repels charge at B and charge at B repels charge at A. So force on A, it is in this direction. Okay, that means it acts along the line joining the two charges. So draw straight line. Okay, so this is the direction of force on the charge at A, and this is the direction of force on the charge at B. So suppose, so we call these two charges Q1 and Q2 for the easiness of discussion. So we write the force on what Q1 which is exerted due to Q2. Q1 means experiences a force due to Q2. So we write it as F12. So F12 is the force on Q1 by Q2. Similarly, this force we write as F21. Okay, so these two forces we are expressing them as vectors. So they are oppositely directed. So when we use this expression, we can see that both the forces, that means F21 and F12, they are of equal magnitude. Their magnitudes will be same. But what about their direction? Their directions will be different. So when we write the vector equation, that will be the difference in that equation. Okay. So to write a vector equation, we take an origin. Suppose this is the origin O. So this position vector of this particular point A at which Q1 is kept, let that position vector be R1, vector R1. So what is vector R1? Position vector of the charge Q1 at A. Similarly, at B, the position vector is, that means charge Q2 at B, that position vector is R2. So R1 and R2 are the position vectors of the positions of two charges Q1 and Q2. Okay. Now how we incorporate the direction? Okay. So in this small diagram, that means a triangle ABO, take triangle ABO. So if we take the vector AB, that vector AB, so you can write, so this is the direction of position vectors. So we can write by triangle law vector OA plus vector AB is equal to vector OB. what I said, vector OA plus vector AB is equal to vector OB. That is what we get from triangle law of vector addition. So we put the arrow mark here like this. Okay. So actually what is vector AB? Vector AB is equal to vector OB minus vector OA. What is vector OB? Vector OB is vector R2 and vector OA is R1. So vector AB is equal to vector R2 minus vector R1. So this is the vector AB. So vector AB is nothing but vector R2 minus vector R1. Okay. Now this vector R2 minus vector R1, that is vector AB. Suppose I write it as vector R21. So it is nothing but vector R21. So it's simply a displacement vector like that. These two are position vector. AB is displacement vector we say, but here the charge is not displaced. Okay, that diagram. So here we call it as, or that distance vector or something like that. So R21 is equal to R2 minus R1. Okay, so when we write the expression for F21, look, F21, what is the direction of force experienced by Q2? This is the direction. That is the direction of what? R2 minus R1 or R21. So in short, F21, that means force on Q2 by Q1 is in the direction of R21. What did I say? Vector F21 is in the direction of R21. So how can we write F21 in vector form? You know how we can incorporate direction in an equation or in a particular value. That means you can write vector A as A into unit vector A cap, where A is the magnitude of vector A and A cap is the unit vector in that direction. We used to write some vector V is equal to 16I, like that we used to write, where this I cap stands for unit vector. So in terms of unit vector, you can write this Coulombs law again. That gives you the vector form of Coulombs law. So F21 we are writing. So what we are writing is F21, vector F21. So vector F21, first one, it's magnitude only. So 1 by 4 pi epsilon 0 Q1 Q2 divided by, here just for the sake of distinction between F21 and F12, I write it as R21 square. So 1 by 4 pi epsilon 0 Q1 Q2 by R21 square into, what I have to add is this unit vector. Here which unit vector? I already wrote F21 is in the direction of R21, in the direction of vector R21. So you need to write a unit vector in the direction of vector R21. So it's enough to write this into R21 cap, where this R21 cap is the unit vector in the direction of vector R21. Okay, so our expression for F21 becomes 1 by 4 pi epsilon 0 Q1 Q2 by R21 square into R21 cap, where R21 cap is the unit vector and its purpose is to show the direction. In which direction is this R21? R21 is in the direction of F21. Okay, so that unit vector is denoted by R21. So this is how we represent Coulombs law in vector form. See, this is only F21. Here you can write F12 also. So what will be the expression for F12? F12 in which direction you look? F12 in this direction. So you have to redefine another unit vector or take the opposite of given one. Suppose we write another one. There the unit vector we write as R12. Okay, so this direction we take as R12. So our expression becomes 1 by 4 pi epsilon 0 Q1 Q2 divided by, so here I write as R12 square into this unit vector becomes what? R12 cap. Instead of R21 cap, I wrote R12 cap. This is how we write the vector form of Coulombs law. Okay, Coulombs law in vector form. So don't get confused. R21 square and R12 square, both are same. See, R21 square equal to R12 square, that is equal to this R square. For the sake of comparison only I wrote as R21 and R1, because in taking square, no, it's no more vector. It's a simple scalar value, that is that distance, that gap between the two charges itself, separation. So that squares R1 square and R21 square are the same as R square. The difference lies here only. Okay, so how are they related? R21 cap and R12 cap, both are unit vectors, but they are directed oppositely. Or R21 is opposite in direction to R12. Okay, or these two vectors we can say F21, it is opposite in direction to F12. We already stated their magnitudes are same. They are equal in magnitude and opposite in direction. Okay, so that statement, the two statement equal in magnitude, opposite in direction, that is incorporated in this mathematical equation. F21 is equal to minus F12, and by this statement we prove, that means this Coulombs law is consistent with Newton's third law. What is Newton's third law? The force of action and reaction, they are equal and opposite. So it is consistent with Newton's third law. So if a question comes, show that, maybe 1 mark or a part of 3 mark question, show that Newton's or a Coulombs law is consistent with Newton's third law. This is how, this is what you have to write. Okay, so though it looks very difficult, means diagram and all what it is, if you concentrate it and look, no, with one glance, at one glance itself you will get it what it is. Okay, so these two equations are the vector form of Coulombs law. Okay, now here one more point we have to make it thorough, that is, usually in question paper and all, or in problems, no, frequently asked questions, we used to see one statement, mathematical statement, some questions, no, conditions will be given. If Q1, Q2 is greater than 0. What do you mean by Q1, Q2 greater than 0? Product Q1, Q2 is greater than 0. Greater than 0 means what? It is a positive quantity. Greater than 0 means product Q1, Q2 is positive quantity. So this is possible only if Q1 and Q2 are like charges. Okay, so instead of directly stating two like charges, they will write if Q1, Q2 is greater than 0. So Q1, Q2 greater than 0 means the two charges are like charges, because if negative, negative, negative into negative, positive, 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 positive also is positive. Negative into negative, positive, positive into positive also positive. So it shows it is like charges. Similarly, if Q1, Q2 less than 0, it shows what? Unlike charge. So these two are points to be noted, or you have to take care of these 2 points. What do you mean by Q1, Q2 greater than 0 and Q1, Q2 less than 0? Now, in the textbook, so we already discussed Coulombs law, mathematical form and all. Now we move on to the 2 example questions. So in the previous session, we already discussed 3 example questions. So now we are moving on to the 4th example. The 4th example, that is example 1-4. So it deals with the comparison of gravitational force and electrostatic force between an electron and a proton and 2 protons. That's what. So once again, what it is? 2 electron means 1 electron and 1 proton. 1 electron is here. This is electron, and here you have a proton. Okay, they are kept at a distance of 1 angstrom. What do you mean by 1 angstrom? 1 angstrom is 10 raised to minus 10 meter. 1 angstrom is 10 raised to minus 10 meter. they are kept at these 2 points. Okay, like this. Now, what about that means ratio of, so there are 2 types of forces between the two, because both electron and proton are having what, mass. So because of that there is gravitational force. Both of them have charge. Because of that they have electrostatic force. So what about the ratio of their forces? So by knowing the ratio we can say which force is more. So that's what we have to do. So first what we will do is we will write the expression for gravitational force and electrostatic force and just take the ratio Fe by Fg. So what is Fg? The gravitational force. What is the expression for gravitational force? F is equal to G m1 m2 by d square, where m1 and m2 are the masses and d is the distance between the two. Distance is 10 raised to minus 10. So when we substitute, so we can write G m p m e divided by that distance, that is 10 raised to minus 10 whole square. That is gravitational force. Here is what? That is 1 by 4 pi epsilon 0 into Q1, Q2. Here the thing is this, both electron and proton, they have same amount of charge. So that we can write the electron's charge, we write E, that is minus E. Here it is plus E. So product when we take, no, that sign you need not consider, because that sign stands for what? Direction, whether it is attractive or repulsive. The force here it is attractive, so negative sign stands for that. So that you need not take here. So that magnitude, it comes E square divided by, here also the distance is 10 raised to minus 10 square. Okay, so we wrote Fg and Fe. So we will take Fe by Fg. Here Fe stands for what? Electrostatic force. Fg stands for gravitational force. So when we take the ratio, it is 1 by 4 pi epsilon 0 G. Numerator you have E square divided by MP ME. This is what? So 10 raised to minus 10 square in both the equation, they get cancelled. And this is what you get. So you can substitute 1 by 4 pi epsilon 0 as 9 into 10 raised to 9. Previous class we discussed. E 1.6 into 10 raised to minus 19. Mass of proton, mass of electron. What is mass of proton? That is 1.67 into 10 raised to minus 27. We will substitute everything. So 1.6 into 10 raised to minus 19 square into 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. That into G is 6.7 into 10 raised to minus 11. Last year gravitation chapter we have studied. Into 1.67 into 10 raised to minus 27, that is mass of proton, and 9.1 into 10 raised to minus 31, that is the mass of electron. So by substituting this we will get around 2.4 into 10 raised to 39. This is ratio, so no unit. 2.4 into 10 raised to 39. In the case of what? Electron and proton, the ratio of electrostatic force to gravitational force. So the ratio is very big, 39, 10 raised to 39, not simply 39, 10 raised to 39. What does it mean? The electrostatic force is 10 raised to 39 times the gravitational force. So compared to gravitational force, electrostatic force is a big force. Okay, it is a big force or a large force or a strong force. That's what we can conclude from this value. Okay, so similar steps we can do in the case of 2 protons. So in the case of 2 protons, the equation just change like this. Here you will have MP itself. This equation same itself. So here you will have MP. So in the substitution also you will have 1.67 into 10 raised to minus 27 square. So by doing this we'll get some other value, that is some 1.36 or something, or 1.3 into 10 raised to 36 we will get. So here also 10 raised to 36, 10 raised to 36, one electron is replaced by one proton. So the value changed to 10 raised to 36. So it is again 10 raised to 36 times bigger than or larger than or stronger than gravitational force. So again it shows that electrostatic force is stronger than gravitational force. So to show that only this problem. Okay, now in that problem itself there is a second part. That second part is asked to find the acceleration of, that means we consider that charges to be that electron and proton. So we have an electron and proton separated by that 1 angstrom distance, and you are asked to find acceleration of this electron and acceleration of proton. So how will we find acceleration? We'll use Newton's second law, F equal to ma. So what is A? A is equal to F by m. So by getting F, you can, by knowing m, you can calculate the acceleration. So first step is to get F. What is F? 1 by 4 pi epsilon 0 into E square, because both electron and proton, they have the same charge, and 10 raised to minus 10 the whole square. So you have 9 into 10 raised to 9 into 1.6 into 10 raised to minus 19 square divided by 10 raised to minus 20. So by solving this, you will get the answer as 2.3 into 10 raised to minus 8 Newton. 2.3 into 10 raised to minus 8 Newton you will get as the answer. Okay, now what we need to find is acceleration. So both you have to find, that is for electron and for proton. So acceleration of electron is what? 2.3 into 10 raised to minus 8 divided by its mass. What is its mass? 9.1 into 10 raised to minus 31. Similarly, acceleration of proton is 2.3 into 10 raised to minus 8 divided by its mass, that is 1.67 into 10 raised to minus 27. So smaller mass is therefore electron. So electron will have more acceleration and proton will have comparatively less acceleration. So acceleration of electron is 2.5 into 10 raised to 22 meter per second square. 2.5 into 10 raised to 22 meter per second square, and for proton is 1.4 into 10 raised to 19 meter per second square. By doing calculation you will get. So doing such calculations, no, you can use logarithm table. Okay, so with that particular example question is completed. So main what concept this problem has to give is what electrostatic force is a big force, that means stronger force, and it is very stronger compared to the gravitational force between the same objects. So that next problem, no, 1.5, that we will discuss in the next session. So only this much for today. Okay, thank you.